The first thing that we need to do in making tablet triturates is that we need to calibrate the mold. If you will refer to the formulation record, you will see that calculations are needed to determine what percentage of a cavity is occupied by the active drug. The way that that percentage becomes calculated is that you have to make two sets of tablets. One set of tablets is the drug alone and is shown as these 5 tablets here. The other set of tablets is made from the base alone, as shown by this section of tablets here. It's necessary to get an average weight of both types of tablets. So we need to extract the tablets from the mold. These have already been extracted, and our tablets that are made from the base alone can be extracted from the mold as follows, and carefully push down on the cavity plate until all of the tablets come off. So we have tablets made of the base alone and then tablets made of the drug alone. The average weight of each kind of tablet is then determined, and the percentage of the cavity in the cavity plate occupied by the active drug is determined. Again, refer to your formulation record. A tablet triturate in general is sucrose and lactose. The amount of sucrose will depend on the drug that is being used. Its purpose is to add firmness or hardness to the tablet. The lactose acts as a diluent and a bulking agent and will depend on how much drug is being added and how much sucrose is needed for the desired tablet hardness. The percentages that are used in any particular tablet are experimentally determined. For these tablets, 40% sucrose provided the desired hardness of tablets. Metoprolol is added so that we have 12.5 milligrams in each tablet, and then the remainder is lactose to make up for the amount of material that the mold will hold. This is a 100 milligram tablet mold, and there are 50 cavities in the cavity plate. Therefore, 5,000 milligrams is the amount of material that can be held by this mold. We will use a wetting solution to begin to dissolve the sucrose. This wetting solution has both alcohol and water in it, and like the percentage of sucrose that is used in a formulation, is experimentally determined. This contains 75% alcohol and 25% water. The alcohol is there to aid in the evaporation of the solvent from the tablets. The water is present to help dissolve the sucrose, which will impart the hardness to the tablet. What we're looking for in this particular process is a time when the powder is wet enough that it will adhere to the pestle, but not so wet that we start to dissolve the metoprolol. Generally, you can start with about 15 drops of the wetting solution. And you'll notice that the powder pack is changing slightly, but certainly not adhering to the pestle. So that we do not add too much of the wetting solution at a time, add only 3 or 4 drops and triturate lightly. Continue that process until one moment in time when the powder adheres to the pestle. You will notice as you continue to add the wetting solution that the powder will become more paste-like. And you can see that some is starting to adhere to the pestle. Again, you can see that the powder is no longer a free-flowing powder, but is much more of a paste-like or aggregate-type powder. To make sure that wetting is uniform, scrape the powders off the pestle because they will contain wetting solution as well. At one point in time, all of the powder will adhere to the pestle. At this point, add 3 more drops of the wetting solution. Triturate lightly and transfer the mass to the cavity plate. Take a spatula and move the mass over several rows of cavities. Then come back and focus on one row at a time. You'll notice that my index finger is down on the spatula toward the very end. I am attempting to apply as much pressure as I can. The amount of material in each of the holes is determined by how tightly you pack the hole. Therefore, use a very strong pressure and fill every hole to its maximum capacity. Once you have completed 2 rows, scrape off the powder and continue to move down the mold to the next 2 rows, packing each of those tablets totally and firmly. Continue to move the material down the mold 2 rows at a time, and again, pack the tablets firmly and completely. If you begin to run out of material, completely fill only the tablets that you can. Do not produce partially filled tablets. It's important to move quickly when you do this because the alcohol is evaporating the solvent and the powder becomes much more difficult to use. It's also a good idea to look back at the tablets where you have left, and if you see obvious gaps, go and fill them in. Again, do not worry about filling the entire mold if you start to run out of material. But be sure whatever you fill is packed tightly. You will notice as time goes by, the powder becomes more flaky, becomes more difficult to work with, and that's simply because the alcohol in the wetting solution is evaporating. Continue to fill as many holes as you can, looking back at previously filled holes, and if there's an obvious gap, go and fill that tablet. Fill as many holes as you can. When you're ready to move the cavity plate to the peg plate, it's best to slide the plate off of the pill tile instead of raising it up. Slide the plate off, put onto the peg plate, and push down gently. The tablets will stay on top of the pegs, but will be pushed out of the cavity plate. Leave the tablets on the pegs to allow to dry. In most cases, they will dry in 1 to 2 hours. After the tablets have had a chance to harden, invert the plate, push down on the cavity plate until the tablets come loose, and your tablets are ready. Metoprolol tablets have a unique reaction that I want to show you. I've made a batch of tablets both on black molds so that they'll be more visually enhanced. The set of tablets on this side, I used a black rubber spatula. If you look at the tablets in comparison to the tablets on the other side, you'll notice that they look gray. Now, one possibility is that the color is coming off of the black mold. A way to determine if that's true or not is to make another set of tablets using a different kind of spatula, stainless steel spatula. And if you look at the tablets made by the stainless steel spatula, you notice that they are quite white as compared to the ones made with a hard rubber spatula. Therefore, the color is not coming off of the cavity plate, but the color must be coming off of the hard rubber spatula, since the stainless steel spatula does not cause the gray tablets. I don't have the plates here to show you, but the same effect happens if you use the aluminum plates, the silver-colored plates. You see the same effect, that the hard rubber spatula is the one that is producing these gray tablets. So, when making metoprolol tablet triturates, it is important to use a stainless steel spatula to press the tablets into the cavity plate. It's also of historical note that in older literature, it was suggested that you use a whalebone spatula to make tablet triturates. And I have to wonder if they knew something about the hard rubber spatula even back then.